let's look at ways of finding the probability of an event of a binomial experiment. We're going to discuss two ways of finding the probability of an event in a binomial experiment. The first method is by using a formula. The formula for finding the probability of a certain number of successes and a certain number of trials is this. Probability of X, and we're talking about X successes in N trials. So X here represents the number of successes. X represents the number of successes that we're trying to find the probability of. We might be trying to find the probability of getting 3 successes in 3 trials, or we might be trying to find the probability of getting 4 successes in 10 trials. If we're talking about reaching in a container of balls, we might be trying to find the probability of getting 2 red balls by using 5 trials. By reaching in the container 5 times, what is the probability of getting 2 red balls? We might be talking about a couple having children. We might be trying to determine the probability of a couple having 2 girls in 5 trials, or having 4 boys in 6 trials, or something of that nature. So we can use this formula here to find that type of probability. So your X here represents the number of successes that you're trying to find the probability of. You might be trying to find the probability of 8 successes in 20 trials. You might have a sample of Republicans and Democrats. You might want to find the probability of getting 4 Republicans in 8 trials, or getting 4 Democrats in 8 trials. So this is what we're talking about here for X, the number of successes that you're trying to find the probability of. So we have the probability of X successes equals N factorial, and we'll talk about factorial and exactly what a factorial is in just a moment. But this exclamation mark there, the exclamation mark is read factorial. Factorial. So this is N factorial, and it's over N minus X factorial times X factorial times P to the X power times Q to the N minus X power. Now, as we said, X represents the number of successes that you're trying to find the probability of. N represents the number of trials. The number of trials, or we can say that it's the sample size. P represents the probability of success in a single trial. So P is the simple probability. The probability of success in a single trial. Once again, P represents the probability of success in a single trial. Q represents the probability of failure in a single trial. Once again, P represents the probability of success in a single trial. Q represents the probability of failure in a single trial. So that means that P and Q are complementary probabilities. And from what we learned about probabilities, we learned that if we know the probability of success, we can get the probability of failure, since it's the complementary probability, by subtracting the probability of success from 1. So this means that Q is equal to 1 minus P. So that if we know the probability of success, we can find the probability of failure simply by subtracting it from 1, because that's the complementary probability. Now, in this formula here, we have the factorial. So that is something that we haven't really had to deal with before. So let's take a look at exactly what we mean by the symbol factorial. If I have 4 factorial, that means 4 times 3 times 2 times 1. If I have 8 factorial, that means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If I have 5 factorial, that means 5 times 4 times 3 times 2 times 1. So factorial means that you take the number that you have there, you multiply it times the next smaller number, the next smaller number, all the way down until you get to 1. And we're multiplying them by the next smaller whole number, the next smaller whole number, until you get to 1. For 8 factorial, we start with an 8, we multiply times the next smaller whole number, the next smaller whole number, the next smaller, all the way down to 1. That's what we mean by factorial. Now we have a definition for 0 factorial. The definition for 0 factorial is equal to 1. This is a definition. This is how we define 0 factorial. So that means that when you see 0 factorial, it's not equal to 0. 0 factorial is equal to 1. And this is what you'll be using in your problems. When you come up with a problem that has 0 factorial in it, you just substitute a 1 for that 0 factorial. Now, so as was mentioned, this formula here that you see enables us to find the probability of an exact number of successes in an exact number of trials. The probability of an exact number of successes in an exact number of trials. Now that we have seen the formula, and now that we know something about factorial, let's take a look at an example so that we can see exactly how this formula works. In your textbook, turn to page 223, page 223, and there you'll see an example that we can use to apply this formula here for finding binomial probabilities. On page 223, the example there, according to one study conducted at the University of Texas at Austin, 2/3 of all Americans can do routine computations. Now, when you read problems in mathematics, it's good to write things down as you go along, especially numbers. So we said that 2/3 can do routine computations. 2/3 of all Americans can do routine computations. If an employer were to hire 8 randomly selected Americans. So we are selecting 8 randomly selected Americans. what is the probability that exactly 5 of them can do routine computations. So we want to find a probability that exactly 5 can do routine computations. We want to find the probability that exactly 5, and these individuals are chosen at random. Exactly 5 can do routine computations. Now, the 8 in this problem, there were 8 individuals that were selected, or we're going to select 8 individuals. So the 8 here represents the sample size. The 8 represents the sample size. So if we look at the formula here, we have X, N, we have P, we have Q. Those are the 4 variables that we have in this formula that we have to know in order to use this formula to find this probability. So the 8 here would represent which one of these variables? Would it represent the P, the Q, the X, or the N? The 8. The 8 represents N. That's the sample size, or the number of trials. So we know what N is. We need to know X, P, and Q. X, we said, represents the number of successes that you're trying to find the probability of. Now, in this example here, we're trying to find the probability of exactly what? Exactly 5, right. Exactly 5 successes. That's what we're talking about here. The probability of exactly 5 successes in 8 trials. So that means that our X here will be equal to 5. X equals 5. We want to find the probability of 5 successes in 8 trials. So the X would be equal to 5, the number of successes that we want to find the probability of. Now, we need to know what P is, the probability of success in a single trial. Now, if you recall, when we studied this topic previously, when we studied probabilities previously, we said that if you have a percentage, that represents a probability. If I know the percentage of freshmen here at this college, that would represent the probability of getting a freshman in a single trial. Percentages can also be expressed as fractions, as you know. So a fraction is another way of expressing a probability. If I say that 1/4 of the students here are freshmen, then it would be equivalent to saying that the probability of getting a freshman in a single trial is 1/4. So in the problem that we have here, it was indicated that 2/3 of all Americans can do routine computations. So this represents the probability of success. A success here was getting a person that can do routine computations. So you have to be sure to read the problem carefully so that you'll know exactly what is meant by success in the problem. Success in a different problem would mean something different. But here, success is getting a person that can do routine computations. And we said that 2/3 of all Americans can do routine computations. So that means that this 2/3 here represents P. The 2/3 here represents little p. So little p equals 2/3. The reason I say little p here is because I don't want you to confuse it with this P of X here. This is a capital P here, representing the probability of X, the probability of X successes in N trials. That's what the capital P here represents. That's the probability of X, the probability that you're looking for. The little p here is the little p in the formula. This little p here, this little p is the probability of success in a single trial. So that's what we're going to use the 2/3 for. That little p, the probability of success in a single trial. Now we need to know Q. We need to know the value for Q. Now, as we said before, Q is the complementary probability of P. So that if we know that P is equal to 2/3, to find Q, all we have to do is take P, 2/3, and subtract it from 1. Just take the probability of success, subtract it from 1, that gives you the probability of failure. So that tells us that Q would be equal to 1/3. Q equals 1/3. So now we have everything we need to use this formula to find the probability that we're looking for. So we just substitute these numbers into the formula for the variables. And then we use our calculators and mathematics, what we know about algebra and so forth, to simplify the expression we get after we substitute those numbers in. Now, we start on the left side of the formula. We were talking about the probability of 5 successes in 8 trials. So that means that the x here would be 5. The probability of 5 successes in 8 trials. That's what we're looking for. So the probability of 5 successes in 8 trials equals n factorial. We found out that n was equal to 8, the number of trials or the sample size. So we can substitute an 8 there for n. In the denominator, we have n again. We can substitute an 8 for the n. That represents the sample size or the number of trials. Next in the denominator, we have x. We said that x represented the number of successes that we're trying to find the probability of. We're trying to find the probability of 5 successes. So the x will be equal to 5. We can substitute a 5 in the formula in the place of the x. Here again we have x factorial. For the x, we can substitute a 5. Now, on the right side of the formula, we have P. We said that P was equal to 2/3. So instead of the P here, we can substitute 2/3. We would have 2/3, and it's to the x power. It was P to the x power. So for the x again, we can substitute 5. For the x again, we can substitute 5. Q, we found out, is 1/3. We just subtracted P from 1, and that gave us Q, which is 1/3. So we substitute a 1/3 in the place of the Q. N, once again, we said was 8. So we substitute an 8 for the N. X is 5. We substitute a 5 for the X. So this is how the formula looks after we substitute the numbers in for the different variables. Now we take out the calculator and we use our knowledge of mathematics and our knowledge of algebra to simplify this. First we start with 8 factorial. We express that, we write that out in terms of what it means. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now in the denominator we have 8 minus 5, which gives us 3. So this gives us 3 factorial here. 3 factorial. If we write that out, so this is 3 factorial. If we write that out in the denominator, it would be 3 times 2 times 1. Remember, factorial means that you take the number that you have there, you multiply it times the next lower whole number, and then times the next lower whole number until you get down to 1. So that's what we do here for 3. Then we have 5 factorial. Now if there's nothing between 2 factorial expressions, it automatically means that you're multiplying those 2 factorial expressions together. So here we're multiplying this factorial times that factorial. So that's why we have 3 times 2 times 1 and then times 5 factorial. Now 5 factorial means 5 times 4 times 3 times 2 times 1. That's what 5 factorial means. Now, for this part of the problem, we have 2/3 to the 5th power. So 2/3 to the 5th power from your study of algebra means that you take 2/3 as a factor 5 times. So you would have 2/3 times 2/3 times 2/3 times 2/3 times 2/3. Now, if you wanted to, you could change the 2/3 into a decimal and round it off to 3 decimal places. 2/3 as a decimal would be 0.667. So if you wanted to, you could do that. Change it into a decimal, make it 0.667, and then if you have an x to the y button on your calculator, or y to the x button, you could use that button in order to find out what this would be equal to. You could say I have 0.667 to the 5th power, and that would be approximately equal to what we have here. Now, for the next term, we have 1/3 to the 8 minus 5. 8 minus 5 equals 3. So what we really have here is 1/3 to the 3rd power, or 1/3 cubed. That's what we really have here, 1/3 cubed. So that means we take 1/3 as a factor 3 times. So we would have 1/3 times 1/3 times 1/3. And then we proceed to simplify this. We can cancel the 1s, the 2s, the 3s, the 4s, the 5s. 2 goes into 2 once, 2 goes into 6 3 times. The 2 3s cancel. We end up with nothing on the bottom but 1. And on top we have 8 times 7, which is 56. So there we get 56. And then, for this part, there's nothing we can cancel here. So we just multiply straight across, 2 times 2 times 2 times 2 times 2. That gives us 32. So we get 56 times 32 over 1, 2, 3, 4, 5, 6, 7, 8. We could say 3 to the 8th power on the calculator. 3 to the 8th power. And that would give us 6,561. 6,561. And then we proceed to multiply the 56 times the 32, and then divide that by 6,561. And that gives us a probability of 0.273. So the probability of 5 successes in 8 trials would be 0.273. 0.273. That's the probability of getting exactly 5 persons that can do routine computations. So we have essentially completed the problem by using the formula for finding binomial probabilities. And we are, of course, here are dealing with a binomial situation. That's what enables us to use the formula, the binomial probability formula. So once you get the answer, you should come back and address the problem. And you should make a statement in the end, at the end of your problem. You should say something to the effect that the probability of getting a person that can do routine computations is 0.273. Or you can write that as a percent. As a percent, that would be 27.3%. There's a 27.3 probability of getting a person that can do routine computations.